Good morning, students. Today we are going to learn the area and perimeter of the circle. In this, we might have seen the circle's perimeter and area, but in this chapter we are going to learn few more things also. So let us start with this table to revise all these things. First is a circle. A circle will be having a dimension r. Then if we consider the area of it, it becomes pi r square, where r is the radius of the circle. Or else if we consider the diameter d, then pi d square by 4 is the area of a circle. If we consider the perimeter, it means this circumference part, that becomes the perimeter. Then it will be a 2 pi r, or in the case of a diameter, it will be pi d. Pi is generally considered as a 22 by 7 or 3.14. Then comes the semicircle, which means a half circle. Then its area becomes pi r square by 4. Its perimeter becomes pi r plus 2r, or you can use pi r plus d diameter. Then comes a quadrant. A fourth part of a circle is known as a quadrant, where the area becomes pi r square by 4. Its circumference becomes pi r divided by 2 plus 2 times r, or pi r divided by 2 plus diameter d. If there is a ring kind of a shape, then its area becomes pi capital R square minus pi small r square. And if you take the pi common, r square minus r square, factorization gives us r plus r minus r. Its circumference is 2 pi r plus small 2 pi r. Then comes a sector. This is a minor sector, and this is a minor segment, this area. Segment is a part of a sector. To consider the sector, if we calculate its area, we have to get the central angle theta. Then the area becomes pi r square theta divided by 360, or else 1 upon 2 L into r, where L is the arc length, that is pi r theta upon 180. The arc length is pi r theta upon 180 degree. If we consider the perimeter, then this arc length will be theta by 360 into 2 pi r. It means pi r theta by 180. This length L plus r, it means 2r. In the case of a segment, this area becomes the segment area. The area of it can be found with the help of sector area minus triangle's area. Sector area that we know, pi r square theta by 360 minus triangle's area can be found by so many ways. If it is an equilateral triangle, root 3 by 4 side square. If it's an isosceles triangle, then we can use the Heron's formula, or by the Pythagoras theorem, if the central angle is 90 degree, then we can use half base into height. But in general, if we use 1 by 2 r square sine theta, then we can find out its area. The segment length will be pi r theta by 180 plus 2 r sine theta by 2, where angle theta is angle subtended by the arc at a center. Let us see few questions related to this chapter. And the first topic of this chapter is perimeter and area of a circle. In which example 1, the cost of fencing a circular field at the rate of 24 rupees per meter is 5,280 rupees. The field is to be plugged at the rate of rupees 0.50 per meter square. Find the cost of plugging the field. So here, the circular fencing is plugging at 24 rupees per meter and we are paying 5,280. So the length of the fence in meters will be total cost divided by per meter cost, that is 220 meters. So that 220 meters will be now circumference of the field. As we know, circumference of the circle is 2 pi r. So we can find out r from it. So r becomes 35 meters. Now, area of the field can be found by this way, pi r square. Pi 22 by 7, r 35. So we get 22 into 5 into 35. We are plugging 1 meter square at 0.50 rupees. Then total cost will be 0.50 into 22 into 5 into 35. At last we get 1925 rupees to be paid. Then the next topic is area of a circle for the sector and its segment. Sector is a part of a circle and segment is also a part of a segment. So let us see one example of it. Find the area of a sector. When there is a word sector only used, we have to consider that this is a minor segments area. And this remaining part will be a major segment. And it will be specified that find out the area of major sector. Otherwise, if sector word is used, we will understand that they are talking about minor sector. So find the area of a sector of a circle with the radius 4 centimeter and off angle 30 degree. Also, find the area of the corresponding major sector. Use pi equal to 3.14. So we can see from the figure. We need the area of O, A, P, B, O. So that is minor sector. Area is pi r square theta by 360 where r 4, theta 30, pi 3.14. So when we solve it, we get 4.19 centimeter square approximately. Now, the major sector is this much area. We can understand that circle's area minus this minor sector area will give us the major sector area. So area of the corresponding major sector is circle's area pi r square minus area of a sector OAPB. So pi r4 square 16. So 46.05, that is approximately 46.1, that is the area of major sector. Alternatively, if we want to use the formula for major sector, then pi r square minus this formula, pi r square theta by 360. Take pi r square common, 1 minus theta by 360. That is 360 minus theta by 360 will give you the area of major sector. Then comes the area of combinations of the plane figures. Let us see one example of it. Find the area of a shaded region in the figure 12.16 where ABCD is a square of side 14 cm. Here this diameter D, it means 2D will be the length of AD, which is equal to 14 cm. So 2D is 14, D becomes 7. So diameter 7, radius of this circle becomes 3.5. That we have proved here. And area of a square, that is 14 into 14, 196 centimeter square. We need this shaded region. It means that area of a square minus 4 times area of a circle. Area of one circle is pi r square, that is 77 by 2. 4 times of it gives us 154. So total square area 196 minus 154 will give me 42 centimeter square. That will be our shaded region. Let us see one more example. Find the area of the shaded region in the figure 12.17 where ABCD is a square of side 10 centimeter and semicircles are drawn with each side of the square as diameter. So here we can see there are 4 parts of this figure, 1, 2, 3, 4. So these unshaded regions marked them as a 1, 2, 3, 4. If I need the area of marked number 1 and area of the marked number 2, then I can find out that area by squares area ABCD minus area of the 2 semicircles of radius 5. because here the side length is 10. So the diameter of the semicircle will be 10, radius becomes 5. So area of ABCD 10 into 10 minus 2 times semicircle area 1 by 2 pi r square, 5 square, that is the radius. So that value is 100 minus 78.5, which is 21.5. The area of this number 2 and 4 will be seen as the 1 and 3, it's 21.5. So if we add those areas, we get 43, and squares area minus this 1, 2, 3, 4 will give us the shaded region. So 100 minus 43 will give me 57 centimeter square. Thank you.